Hello. Okay. So we got through the first chapter of Perio, right? So Perio, chapter 1, we got it. Now we review that a few times and we're going to move on to chapter 2, okay? Test is tomorrow, so I'm going to try and get through these. So we have some videos. Everybody learns different, so I'm just trying to reach out. This, for me, reviewing it out loud helps me. And, videos help other people too sometimes. So that's what these are for. So chapter 2, I did label these if they have a star or not. So if you just want to focus on the things with the star, that's fine. It's totally up to you, but I'm going to go through everything I have, just because you just never truly know. So, all right. So let's get started. Okay, this is chapter 2 of our first Perio exam. Okay. So, number 1, you ready? Oh, first, make sure you get all of your study materials and settle in, get comfortable. This might take just a little while, okay? But like I said, I'm going to try and breeze through them so we're not sitting here for a whole freaking hour per chapter. We know there's 6, okay? So let's do it. What structure joins cell to cell in gingival epithelium? This has a star. We need to know this. What structure joins cell to cell in gingival epithelium? Desmosomes. Remember those cute little things? Little desmosomes. Desmosomes connect cell to cell in that junctional epithelium. Actually, it's in gingival epithelium. So all of that stratified squamous epithelium, all those cells have to attach to each other. Otherwise, they just be loose and everywhere, right? So how do they attach to each other? Desmosomes. They're like Velcro. Cell, cell, boom. Little desmosomes right in between, like Velcro. Desmosomes. Okay? What structure joins cells to the basal lamina? Okay, so we know we've got that basal layer where all the cells, attach to. So we've got our layer and the cells have to attach here and to each other, right? And build up. So we've got that basal lamina and our cells have to attach here and underneath is the connective tissue, right? So how do they attach here? Hemidesmosomes, which means half a desmosome. So they've got this Velcro here. My knuckles will be the Velcro. So cell to cell, they Velcro together, desmosomes. But when it goes here, you only have one of those knuckles Velcroed. So hemidesmosomes, desmosomes. Cell to cell, desmosomes, hemidesmosomes. Okay, that's a star. We need to know that. 3. How do cells attach? Mechanical attachment of cells and their cytoskeleton to other cells. There's no star on this, but it's highlighted. So cells attach to other cells mechanically. So mechanical attachment. It's not chemical, it's mechanical. They actually connect with a mechanism, the desmosome. Okay? Which the junction strengthens tissues to withstand external mechanical forces. We know that they need to stand together so they can, not get pushed down. And then, junctions in sulcular epithelium allow passage of cells and fluid. Well, we'll get to that, but we know we need some fluid going in and out of that sulcus, right? Because the sulcus is a fluid-filled space, right? And certain antibiotics, I believe it's tetracycline, when you're taking that, it's a strong antibiotic and it pushes that fluid through that semi-permeable sulcular epithelium into the sulcus. But I don't know if that's in this chapter whatsoever. I don't know. But just know that cells attach to other cells mechanically. So it's mechanical attachment of cells and their cytoskeleton, so their cell skeleton to other cells. So basically mechanical. All right, let's see. How do desmosomes attach? To another desmosome, like another cell. To another desmosome of another cell like Velcro. We just went over that. A desmosome attaches to another desmosome mechanically by Did I say that right? A cell attaches to another cell by a desmosome, which is a mechanical attachment like Velcro. Okay? Boom, boom. Okay. This is a star. What separates the gingival epithelium from the connective tissue? All these cells up here are going to be our epithelium. Down here is our connective tissue with all the blood vessels. This is a star. So what separates the gingival epithelium from this and the connective tissue? It's the basal lamina. So basal lamina, it's a membrane. If you pull off the skin, the basal lamina comes off with it. I've got a little picture. Oops. This right here, that purple string is your basal lamina, okay? Basal lamina. And the basal propria was the actual connective tissue. Propria. Don't know how we can remember that. Person, it's part of a person. Basal propria. All of these are prioritized to get blood to you and lymphatic tissue and nerves and stuff like that. Down here, this is the basal propria. This is the basal lamina. It's just like a line, a basal line that separates the epithelium and the connective tissue. Okay, boom. Okay, so where does the blood supply to the gingiva come from? We know this. The connective tissue. Obviously, the connective tissue has all those blood vessels and nerves and all the good juicy stuff down here that supplies the top layer. We know this. Okay, what is keratinization? We know this too. Keratinization is a process that involves cell changes from the basal layer of the epithelium to the outer layer at the top. So when it's down here, they're pretty little, beautiful little squares. And as they go up and up and up, they end up losing their nucleus, and then they end up flattening out and become that stratified squamous epithelium, So keratinization is that process that when they're growing up and up, they lose their nucleus and then they become keratinized flat. Yes, it's just a cell change from the basal layer. So the bottom layer, this is our basal lamina, and this is our connective tissue. So right here's all of our epithelium. Okay, so the basal layer is the bottom layer of that epithelium, and it grows up and up and up. They lose their nuclei, and then they become flat cells, and then they shed off. Okay, what do basal cells contain? What do basal cells contain? Well, let's think about this. We know basal cells go up and up and up and keratinize. So these basal cells contain keratinocytes, okay? Little cells of keratin. So the basal layer has keratinocytes, and all those cells go up and up and up, flatten, lose their nuclei, plural, and flatten and shed. Not too bad. What are keratinocytes? Cells that produce keratin, a tough fibrous protein. We know this. Keratinocytes is a site that's going to produce keratin, and keratin we know has to be tough. We need everything tough. So keratinocytes, they are cells that produce keratin. It's a tough fibrous protein. Okay, we need the protein. Proteins are good. Building blocks, right? That's amino acids. Scratch that. Keep moving. How is keratin functional? It makes tissue tough so you can eat and chew. We know that. This is all keratinized. Everything outside of the sulcus in our mouth is keratinized so that we can eat and chew. It makes tissue tough. Keratin makes tissue tough. We got that. How do keratinocytes make their way to the top layer? We've already answered that too. So, cells continuously divide and are pushed up to the surface, the outer layer. So they divide, and as they get up, they lose their nuclei on the way up, and then they become flat and turn into keratin. Keratin layer highly resistant to wear and tear because it's rough, tough, fibrous protein. Okay? All right, good. This one's not starred. What do Merkel cells attach to? sensory neurons. I don't think that's going to be on the test, but if you hear anything about Merkel cells, it's going to have to do with sensory neurons, okay? Merkel, Steve Urkel, he is a nerdle. Okay, no, I try to rhyme, but sensory neurons, if you know who Steve Urkel is, so sensory neurons, Merkel cells. Merkel, Steve Urkel. I think of a nerd. I'm a nerd though, so it's all good. So Merkel, Steve Urkel starts with an N-E, nerd, neurons, okay? So Merkel, Steve Urkel, sensory neurons, okay? Sensory neurons. He's a sensitive nerd. Okay, well, whatever you want to think of. But that's cool. So Merkel, Steve Urkel, sensory neurons, okay? If you overstimulate the gingiva, what happens? Okay, let's think about this. If you overstimulate the gingiva, what's going to happen? It's going to over-keratinize, okay? Not sure how to remember that, but just know that if you overstimulate your gingiva, you keep brushing, it's going to get raw, right? It gets raw and hard and rough. Maybe not so much. Maybe it just gets sore, but still, over-keratinization. So that means they're really trying to put those layers on. Okay, there was no star there, so I don't think that matters. But just in case, overstimulation of your gingiva is going to be over-keratinization. So, star on this. What is the gingival epithelium and what is it composed of? Oh my goodness, we know this, okay? What is the gingival epithelium and what is it composed of? An avascular layer of stratified squamous epithelium. It's avascular because that top layer doesn't have the nerves or the blood vessels or anything like that. The connective tissue does. The connective tissue is what supplies that stratified squamous epithelium, right? So our gingival epithelium is avascular. There's no nerves, there's no blood vessels, there's no anything there. Comes from the connective tissue. So it's an avascular layer of stratified squamous epithelium, layers of flat cells. The blood supply and nutrients come from the connective tissue, we know this, and it is composed of oral epithelium, sulcular epithelium, and junctional epithelium. So everything inside of our mouth that's outside of the sulcus is keratinized. There's only two special epitheliums in our mouth that we will get into here in a minute, which is your sulcular epithelium and your junctional epithelium. And we kind of have an idea of what that is, and that's down in the sulcus and at the bottom of the sulcus, okay? So those are specialized epitheliums that we'll get into in just a minute, but everything outside of the sulcus is called oral epithelium, which makes sense. It's in your mouth. So oral epithelium, sulcular epithelium, and junctional epithelium are your three types of gingival epithelium. Okay, are you with me? This is good. We know about the gingival epithelium, your oral epithelium, okay? It's all in the oral cavity. So oral epithelium, we know what the sulcus is, right? Here's our tooth, here's our free gingiva. We know what the sulcus is. We have our sulcus, and then at one point when it junctions, it's another specialized layer. We'll get into this in just a minute. Okay, so which gingival epithelium is keratinized? There's a star here. We know this. We're going to get this. We got this. It's the oral epithelium. Everything outside of the sulcus is oral epithelium, and it is keratinized, okay? So, we got this. What are the cell layers of the oral epithelium, top to bottom? There is a star on this, so let's check this out together and see what they're talking about. So, what are the cell layers of the oral epithelium, top to bottom? Okay, cool. Ready? Here we go. So, there are 4 layers in our oral epithelium, everything outside of the sulcus. Remember, it had several layers, so I'm guessing some of these have a few layers to their one category, okay? There's 4 layers. The top layer, we know we want it keratinized, nice and strong, right? Let me do this backwards. I'm going to start from the bottom up, okay, because we know this. Here we go. Bottom, here's our connective tissue. What they want to know about the oral epithelium, This right here was our basal lamina, okay? This separates, it's that base line, right? It separates the epithelium from the connective tissue. So we have our basal lamina. And then we have our basal cell layers at the base. And then we have non-keratinized layer because they're still losing their nucleus. And then when they get up here, they're keratinized, flat cells with no nucleus, right? Boom, 4 layers. Put your arm up. This is your basal lamina, your base line, okay? That separates the epithelium from the connective tissue, okay? So our basal lamina, then there's our basal cells. It's our basal cell layer. And then we have our non-keratinized layer as they transition into keratinized layer. Easy. There's your 4 tissues of your oral epithelium. If it's keratinized, this is going to be the way that it goes, okay? Basal lamina, basal cells, non-keratinized, transition, keratinized, okay? Easy. So the keratinized layer, cells have no nucleus. It's a protective function. We know this. Non-keratinized layer, cells have the nucleus still. They're in transition, and they act as a cushion. So there's going to be some layers there, right? Don't you think? So this is your cushion. So you've got your strong, fibrous, dense, fibrous protein, right? And then you've got your cushion, and then you've got your basal cell layer are the cells. They're cube shaped, and they attach to the basal lamina. We know this. We just went through this. Your basal lamina, your basal line that separates both of these, is a tough mat of extracellular matrix and separates epithelial cells from the connective tissue. So this is like a tough mat. So a doormat. It's like a doormat, and we're just going to stack up some Amazon packages, okay? Think of it that way, because your basal cells are square like boxes, and you're just going up and up and up until they are so heavy they're just squashed. Well, no, because they don't squash down here, but yeah. So you have your doormat, that thick, tough doormat, extracellular matrix that separates this. You have your Amazon packages left on the doorstep, those boxes. And then we know there's a cushion there, and then flat, okay? That's your oral epithelium. You with me? All right, next, we're going to zoom through these. We got this. So this is a star. What are the basal lamina papilla called from the connective tissue viewpoint? Okay, fun fact. Your basal lamina, when it comes to the epithelial cells in the connective tissue, your basal lamina is actually not a straight line. It's going to be like a roller coaster almost, because it wants to increase that surface area. I don't really know why. I'd imagine it's to get blood everywhere, maybe, possibly. But, so anytime you see anything go like this, it's to increase surface area. There's a reason. I just don't know it. And it's not starred. So, I just know that increases surface area. So, what are the basal lamina papilla, which are the roller coaster rides, called from the connective tissue viewpoint? So we want to be connective tissue. We're going to look up here and we see all the papilla, right? So the top of the papilla is called connective tissue papilla. Oh my goodness. So we're in the connective tissue, and we're looking up. This is our viewpoint. So we want to know what the top of our humps are. The top of our humps are the connective tissue papilla. That makes sense, doesn't it? So we are from the connective tissue viewpoint. I see the connective tissue papilla. That's so easy. All right. Next, there's a star here. So what are the valleys of the basal lamina called from the epithelial viewpoint? Star. Here's our lamina, our basal lamina that we know is not really a base line. It's more like a base roller coaster, but we'll call it a base line. So we know it's basal lamina. So what are the valleys? So you've got your high papillas, connective tissue papilla, and you've got your lows, your valleys. Okay, so we're epithelial cells now, and this is our viewpoint. So we're going to look down. What are our valleys? We know the humps are connective tissue, right? Papilla. But what are the valleys? Okay. So the valleys are the epithelial ridge. Epithelial ridge or reedy pegs or pegs, P-E-G-S. You pronounce it how you want to. I'm sure we'll be corrected, but we need to know this. So we have the connective tissue papilla and the epithelial ridge, aka reedy pegs, okay? Reedy pegs, okay? So Pete lives in West Virginia, okay? I can't help myself. Whenever I think of valleys and stuff, I think of West Virginia. That's where my honey's family's from. So there's highs, there's mountains, there's lows, there's valleys, okay? So we've got a ridge around a mountain, right? So epithelial ridge, or Pete has legs that he walks around. So when I'm driving through the mountains, I'm afraid, because when you're in West Virginia and you look down, those are some real mountains and it's a straight drop down. So I tell my honey, I want to get out and walk, okay? I want to use my legs. I'm afraid to be in the car on those kind of deadly turns. So when we're thinking we're up top, we're at the top of the mountain, and we're going to see what's coming around the mountain is the epithelial ridge, but this is going down the valley. So epithelial ridge, or reedy pegs, but just thinks Pete's legs. I don't know. Pete for pegs, like R-E-T-E-P-E-G-S. So reedy pegs, Pete legs, okay? So reedy pegs. If you want to remember it that way, because I'm going to get out and walk around those mountains, okay? If you want to remember that, that's fine. If not, just know epithelial ridge, Petey Riggs, okay? Moving on. This says explain sulcular epithelium. Okay, well, we just went through the oral epithelium. We know all of our 4 layers, right? We have the basal lamina, basal cell layer, non-keratinized layer, and then the keratinized layer. Now we want to know the sulcular epithelium. So as you go over that gingival margin and you go right into the sulcus, so this little space right here, as soon as you get in here, the tissue changes, okay? It's specialized for that sulcus, okay? So fluid has to be there, and that's, we'll get into this later, but that's what feeds that subgingival calculus and stuff like that. There's a lot that goes on with that fluid, but your sulcus is a fluid-filled space, okay? And so this sulcular epithelium has to be specialized so it can be semi-permeable and get fluid in and out of there, okay? So bear with me. Explain sulcular epithelium. Let's find out. Okay, so anytime you're in the sulcus, okay, anytime you're in the sulcus, it's going to be non-keratinized, meaning you're always susceptible for disease down there. That's why it's so important to keep the calculus and the little buggy bacterias out, okay? So here's your tooth, here's your sulculus. So sulcus. So this is non-keratinized, okay? Unless stimuli promotes perikeratinization. Big words. It's going to be non-keratinized unless, let's say, they've got a lot of recession and that's overstimulated or something, and then it's going to over-keratinize, so it becomes keratinized. That's how I comprehend it, but we're not going to worry about that. We're just going to know that the sulcular epithelium is non-keratinized unless it's promoted, okay? It's less protected from infection. We know it's semi-permeable because those fluids have to get in there from somewhere, right? And it permits passage of fluid. Well, that's what semi-permeable means. We know this. We are adults, okay? We've been there, done that. Anatomy 1 and 2, okay? So, semi-permeable, we have the fluid going in there because the sulcus is a fluid-filled space, okay? Semi-permeable, non-keratinized, and it is susceptible to infection, okay? Easy breezy. That's the sulcular epithelium. There's a star here. What is epithelial attachment? Okay, so epithelial attachment, it's the body's attempt to close the opening of epithelium caused by erupted teeth, excuse me. So, okay, let me read that again. What is epithelial attachment? So what is the epithelial cells attaching? Like, why are they attaching? Okay, so what is it? What is the attachment? Why does the body attach? Why does the gingiva attach to something? Why? Why does it need to do that? It's the body's attempt to close the opening of the epithelium caused by erupted teeth. So when you're This is weird. Okay, so when your tooth is erupting, right? It's erupting. Actually, let's go on an angle. It's erupting, so there's going to be some space. You see that space? It's erupting. So that's so weird. So your gingiva is going to attach to it, so that way it keeps out the little buggy bacteria, okay? So it's your body's attempt to close the opening of the epithelium caused by erupted teeth. So it's going to attach and try and keep, it wants to protect itself, and that's the best way it knows how, okay? It attaches junctional epithelial to tooth. Oh, we know this. So let's read the question again. What is epithelial attachment? The junctional epithelium attaches to the tooth. We know this. Junctional epithelium attaches to the tooth to keep it's the body's attempt to close the opening of the epithelium caused by erupted teeth. That junctional epithelium is going to attach, okay? So there's an internal basal lamina and an external basal lamina of the junctional epithelium. Okay, well, just because it is the junctional epithelium does not mean it does not have a bottom layer that separates it from the epithelium to the connective tissue, right? Okay, so we have, let's see, the epithelium attachment. We are in the junctional epithelium right now, okay? We're talking about junctional epithelium down, because that's what attaches. So this attachment, okay, it attaches. It comes down and around because it has to attach to something, right? I wish I had a picture. So you have an internal, and an external, okay? Let's see. Let me see if there's a better way to say this. Not really. Okay, so let's see. Junctional epithelium. Tooth, junctional epithelium is where they touch, right? So you see, this is touching the tooth, the root, the cementum and stuff. And then you've got this side that's got to touch something else, right? There's whether it's periodontal ligaments or a bone, whatever that may be. But it attaches to somewhere. They come down and they loop, okay? So the external base, the part that's not touching the tooth, okay? The external base, away from the tooth, connects to the lamina propria, the connective tissue. Okay, so under here's connective tissue, okay? So you have your junctional epithelium, right? Here, what did this say? Junctional epithelium is where they're touching. My hand represents the external because it's touching something else. On the other side of my hand is going to be some connective tissue. So what separates epithelium from connective tissue? A basal lamina, right? So this is the external basal lamina, and that connects to the lamina propria, which is another name for connective tissue, and that connects by hemidesmosomes. It's not connecting to other cells, it's connecting to tissue, right? It's connecting to the basal layer. So it's all connected by hemidesmosomes. And same thing with the internal base. So the internal base attaches to the cementum. See, because we're on the tooth, we've got cementum down here. So, and enamel. So this junctional epithelium attaches to the enamel and cementum, which is this hand. And that's going to be by hemidesmosomes as well. So we have internal is the tooth. External is the connective tissue. So external and internal, okay? Here's the connective tissue over here where my face is, okay? And anytime you have epithelium, you're going to have it attached to connective tissue by a lamina propria. And the junctional epithelium, since it comes down and goes like this because it's specialized, it has an internal and external, okay? I hope you're following along with that. I hope that makes some sense. But we're cruising through this. We're getting through. We're like over halfway done. Okay. So, and this is chapter 2. Once we get this down, we can move on. The sulcular and junctional epithelium are both, drum roll please, non-keratinized. We know this. The junctional epithelium and the sulcular epithelium are both non-keratinized. They are both semi-permeable, so the junctional epithelium can also send some fluids and juices in there. and they have a smooth interface with the connective tissue. So instead of them having that connective tissue papilla and that reedy pegs, epithelial ridge, they're just going to be more of a smoother interface. It's pretty much just smooth interface, okay? So this is a star. What lies between the internal basal lamina and the enamel? So here's our tooth. This is our enamel. This is our cementum. Here's our junctional epithelium. So we know the junctional epithelium down in here is what is the internal lamina, basal lamina. We know there's going to be, see where my pinky is? Okay, nope, that's not going to make sense because that's my external. Well, there is a little space right here. You see this little concavity? So when that attaches, there's going to be a little space there, okay? And so what lies between the internal basal lamina and the enamel, okay? So what lies in between the internal basal lamina and the enamel? What's that little space? Maybe I can make that. Okay, maybe not. But what's that little space there between the internal base and the enamel? Oops. It's called a dental pellicle. Well, this is great. This is great. We know pellicles help attach things. They're like adhesive tape, both sides, you know. So awesome. We want to know, how does that junctional epithelia actually touch the tooth and stay there? There's a little dental pellicle there that attaches that tissue down the internal up to the external, and then you have that little layer that is connected to the connective tissue. Whoo, that's a mouthful, but do you understand a little bit? Like, are you getting it a little bit? So that's not too bad. So that little junctional epithelium here, that junction right there, is attached to the tooth by a little dental pellicle. That's between the internal and the enamel, okay? Awesome. Awesome, awesome, awesome. So think internal because it attaches the enamel and the internal. That's where the internal is where it attaches to the tooth anyway, not the connective tissue that's external. So yeah, a little dental pellicle is right there attaching both of those. Okay. Connective tissue composition. So I don't see a star on here, but we'll just go over it real quick. So connective tissue composition, everything underneath that basal lamina. So this right here, so it's actually called basal papria is the other name for connective tissue. It's a person's connective tissue. So we have cells compose only 5% of gingival connective tissue. And include, okay, so weird. So 5% down here, 5% has to do with the gingival connective tissue because there's a lot of stuff down here. So I'm going to just top layer 5% deals with this. It consists of fibroblasts, macrophages, lymphocytes, neutrophils, and mast cells. So a lot of those white blood cells. That makes sense. They want to keep things clean. They're right there in case we get infection. They could shoot right through and help us out there. They'll give us our inflammatory response. So just know that down here in our connective tissue, we have fibroblasts, which build matrix of fibers and ground substance. Fibroblast. Wow, they build fiber. Fibroblast builds fiber. That makes sense, right? And then macrophages, lymphocytes, neutrophils, or white blood cells. Macrophages are just like there to help clean up the debris, I guess. And mast cells are involved in inflammation and allergic reactions and stuff like that, okay? Collagen fibers, no star, provide firmness and resiliency. Okay, they compose about 60% of gingival connective tissue. They're made of proteins. Amino acids. Proteins are amino acids. Wow. Okay, so they're the building blocks. Awesome. Okay, so we want to know how those are built. Those are built from collagen fibers. Collagen and keratin. This is great. So building blocks, collagen. Ground substance, gel-like. I don't think we really need to know this. It's in my little Quizlet if you guys want to see that, but I honestly, this says ground substance is gel-like, made of proteoglycans, which are a type of protein, holds together collagen fibers, cells, nerves, and blood vessels. So it's basically just talking about what holds all this together. what holds all of this together is the ground substance, okay? Holds all those cells, all that stuff together. It allows passage for water and nutrients and forms 25% of gingival connective tissue. So you've got collagen fibers, which are the firmness and the resiliency of that nice thick connective tissue, 60% of building blocks. And then you've got the ground substance, which is like the gel that holds it all together, 25%, okay? Okay, here's a star. What does the connective tissue papillae and reedy pegs produce? Okay, we know this. What does the reedy pegs and the connective tissue papilla produce? There's a star. It produces stippling. We know this. Stippling is made by the way that the connective tissue is connected to the epithelium, which would be at the place that we see the epithelial ridge, reedy pegs, or the connective tissue papilla. Okay, so nice, we got that. What does not have a wavy interface with connective tissue? Before we answer that, there's a star here, but we kind of already answered this. So we know that this right here happens in oral epithelium, right? Where does it not happen at? What does not have a wavy interface with the connective tissue, right? Connective tissue epithelium, wavy, that's oral epithelium. What does not have a wavy interface with connective tissue? We know this. Sulcular epithelium and junctional epithelium. Okay, so they say the sulcular epithelium and the epithelium attachment. Well, we know that the epithelium attachment is the junctional epithelium. Junctional epithelium, epithelium that junctions to the tooth, that attaches to the tooth. So don't get confused with that on the test. So sulcular epithelium and the epithelial attachment, which is the junctional epithelium, does not have the wavy interface with the connective tissue. We know that. Okay, almost done. What gingival fiber must we know? There is a big star on this. This is the only gingival fiber that we actually truly need to know. So circular, or it's called semicircular, but it's the ones that go around the tooth. So that is a gingival fiber, not a periodontal. It's not down there holding the tooth into the bone. This is a gingival fiber. This is the one that helps attach the gingiva to the teeth. So the only gingival fiber that we need to know for this test is the circular, semicircular gingival fiber, which surrounds the tooth, you know, because like the free gingiva, right? You got your free gingiva. There's little fibers in here too. It's all microscopic. There's little fibers that surround the tooth inside of that cozy free gingiva, okay? So we need to know that. So the origin of these gingival fibers, the circular fibers, encircles the tooth in free gingiva. Oh my goodness. And what is the function? It supports the free gingiva. So here's our turtleneck. We have free gingiva. If we didn't have anything attaching it, wouldn't it be like just really free? Even though there's just a little bit of it, it'd be like kind of really loose, right? So it encircles the tooth in free gingiva and supports the free gingiva. Circular gingival fiber. Circular gingival fiber. Circular gingival fiber. What surrounds the tooth anyway? They have a turtleneck. What is that circle thing? It is free gingiva. Well, what does that connect to? Gingival fibers. Well, what kind? The circular gingival fibers, and it supports the free gingiva. Pretty cool, right? What is biological width? Biological width, no star, but it says 1 millimeter of junctional epithelium and 1 millimeter of fibers. Okay. Body will maintain biological width no matter what separates the inside and outside. No matter what separates inside and outside. So no matter what, if your gums are receding, so is your bone. That's the biological width. It's always going to be the same. It's just going to resorb, but this is the distance they want to stay in touch with and away from each other. Your gums and your bone, okay? That crest right there, the crest. And then, you know, so biological width never really changes. Even in recession, they want to stay the same width apart. In recession, if this is decreasing, this is going to also decrease, and they're going to keep that biological width. So it's really 2 millimeters. One of the junctional epithelium and one of fibers. That's how I don't know if you can see that, but there's the bone, there's the junctional epithelium. This is 2 millimeters. That's how much it wants to stay away from each other and stay together at the same time. 2 millimeters is pretty common. That's the same 0.5 to 2 millimeters is free gingiva too. Okay, so what is included in the attachment apparatus and what is it? What is included in the attachment apparatus and what is it? We know this. So things that attach the tooth to the socket, not the periodontium, not the whole thing, but the attachment apparatus, the actual attachment mechanisms. We know, we know the gingiva helps attach that stuff in there, but we want to know the mechanisms that actually attach it into the socket. Gingiva just helps hold it in there. We want to know the attachment apparatus. Periodontal ligaments, we know, attaches to the cementum and the bone, right? That's the attachment apparatus. So you have the tooth, cementum, periodontal ligament, bone. Okay, that's the attachment apparatus. Okay. All right, so next, there's a star on here. What are the 5 functions of the PDL? Periodontal ligaments, they've got functions, and they've got 5 functions. Let's see what they are. So the periodontal ligaments, we know, suspend the tooth in the socket, right? Like rubber bands, it suspends it. So support. So the periodontal ligaments are going to help support the tooth. It attaches the tooth to a bony socket and suspends while protecting the bone. Periodontal ligaments, supportive, okay? Supportive. It helps support everything. Supports the tooth into the socket while protecting the bone, okay? Supportive. It's also sensory. So nerve fibers transmit tactile pressure. So whenever there's pressure, those periodontal ligaments, they can compress. They don't like pressure. So if you're pushing on them, they can be like, yo, they can send that through the dentinal tubules straight to the pulp because they're in the cementum, aren't they? Embedded into the cementum. They can get into the dentin. So dentinal tubule straight to the pulp. So supportive, sensory. They're also nutritive. So blood vessels provide nutrients to cementum and bone. So these periodontal ligaments also, you've got inside a bone, we talked about this already. In the cancellous bone, there's bone marrow, which produce blood cells and stuff like that. So it wants to, get that out there. So it'll go through the cortical bone, all that. And what attaches to the bone? The periodontal ligament, right? So that blood, it's going to help put the nutrients and the blood and stuff all the way over here into the cementum, which goes into the dentinal tubules, into the pulp chamber. It's also supplied by the apical foramen of the, apex of the root, but that's a whole different thing. Just for learning purposes, just bear with me there. So we have supportive, sensory, nutritive, it's got to feed it, and formative, contains cementoblasts and osteoblasts. So we know that the periodontal ligaments, so they support, they are pressured, so they sense things, they provide nutrients, and they're formative, meaning they have cementoblasts and osteoblasts. So bone and cementum are in there because for orthodontic, they I don't really know how to do that, but just know formative. And resorptive. Resorbs bone and cementum in response to pressure. So if it's pressure, because it has those cells in there, it can reduce bone, resorb. And formative because it can produce on the other end, so that's cool. So it contains a cementoblast, osteoblast. So it can form this way, but resorb this way. Think of that. Orthodontic movement. So you have formative and resorb. Okay, so supportive, sensory, nutritive, formative, and resorptive. Formative, resorptive, okay? Whew! All right, what cells are mostly in the PDL? Fibroblasts. Well, they are fibers, so you would think fiber building cells would be there, right? They're going to help. So fibroblasts. So they are periodontal ligaments. Fibers, right? They're fibers. They're periodontal fibers, periodontal ligaments. Sharpie's fibers, not Sharpie's ligaments, Sharpie's fibers. So in the PDL, you're mostly going to see fibroblast, fiber building cells, and osteoblasts, and cementoblasts. Okay. What are the 5 PDL fibers? Big, big star. So we know we have 5 of them. We have the alveolar crest fibers. We know those at the top. We have horizontal underneath that, right? And then we have our oblique fibers, our apical fibers, and our interradicular fibers. Okay, we know about those. So, give position and function of alveolar crest fibers, okay? We know where they're at the alveolar crest, right? There's a big star here. So the position of alveolar crest fibers, cementum down to the alveolar crest. Position. I'm not really sure I follow. Okay, so does cementum go all the... Oh, it does. So cementum's all the way up here, so down. So cementum is all the way up here. If you can't see it, I can. It's right at the bottom of this tooth. Obviously, starts the cementum. So it's from the cementum down to the alveolar crest, okay? And the function is to resist horizontal movement. Okay, well, let's think about this. Cementum to the bone. Well, that makes sense. It's right here. The crest of the bone to the cementum. We don't want it to go sideways, so they're going to be all right there, okay? Ow, we don't want it to go sideways. I don't know if that's the best, but alveolar crest, don't go sideways. No horizontal, okay? Alveolar crest. I got it. Crest toothpaste, okay? Crest toothpaste, don't brush horizontal. Don't brush like this. We like circles, okay? So don't brush like this. So alveolar crest, horizontal, okay? We don't want to go horizontal. So that resists horizontal movement. Alveolar crest toothpaste, resist horizontal movement. Got it. Position and function of horizontal fibers. Star. So we know cementum to bone below the alveolar crest fibers. So we know that if the cementum to the alveolar crest is the alveolar crest fibers, right underneath that is going to be our horizontal fibers, right? And underneath that is oblique, but we'll stay right here with the horizontal fibers. And that's going to resist horizontal pressure. Let's go back. So, alveolar crest resist horizontal movement, right? Horizontal movement on your brush. That's horizontal movement. That's not pressure. So alveolar crest fibers is resisting horizontal movement, whereas horizontal fibers resist horizontal pressure. They don't want that pressure. If they did, the bone's going to have to resorb and things are going to have to happen. Okay? So horizontal fibers resist horizontal pressure. They don't want to pressure those ligaments. When they're pressured, bad things happen. Bone resorbs, right? Okay. So we have the alveolar crest fibers, horizontal. Then we're going to go to oblique under that. So, star, position and function of oblique fibers. Position apical to... Okay, that makes sense. Okay, position is apical to and diagonal below the horizontal fibers. We have our... I don't know if you can see this. Alveolar crest is from the top of the bone to the cementum. All that's alveolar crest fibers. Then we have... Oops, well, we might as well bring it up. All right. Perfect. Okay. So from the crest to the cementum, which is right here, all of those are going to be your alveolar crest. Crest toothpaste, it resists horizontal movement. Then we have our horizontal right up here. It's going to be horizontal, well, right here below those. Horizontal fibers. And what those are going to do is they're going to resist the horizontal pressure. They don't want that pressure. Those ligaments want to stay right where they're at. Underneath that, you're going to have apical to and diagonal to the horizontal fibers, right? And there's the most numerous of these. I don't know if you can see it on here, but there's a whole lot of oh, actually, I don't think that shows it very well, but there's a whole bunch of oblique. Think we've got a lot of obliques here, right? Kind of, maybe, I don't know. I don't. Some people might, but so obliques are the horizontal fibers, and they're the most numerous. And what they're going to do, the oblique fibers, oh, maybe they go this way. Nope. Okay, the oblique fibers are going to resist vertical pressure. So you got pressure, pressure. So you've got your horizontal fibers resist horizontal pressure. Your obliques are kind of sideways, and they're going to resist vertical pressure. When you're crunching your obliques, you don't want to get up afterwards, right? You don't want to stand vertically. You want to just lay down, lay out for the count. So your oblique fibers are resisting vertical pressure, okay? So you've got alveolar crest, right? Toothpaste resists horizontal movement. You've got your horizontal fibers resist horizontal pressure. Another pressure, oblique, resists vertical pressure. Okay, and they're the most numerous. We got a lot of obliques, and we do a lot of sit-ups just to get those obliques looking right. Hey. Okay. I don't, you do. Okay. So position and function of apical fibers. So we know it's not on this, but we know all the way down at the apex of the tooth, there's some fibers that are connecting it down into the bone. There's a star on this too. And position is obviously apex to the bone, so at the bottom. And it resists lifting forces. So not vertical pressure. We have our horizontal movement, horizontal pressure, vertical pressure, but the apex, it's connected to the bottom because it wants to resist lifting forces, okay? It doesn't want to lift out of the socket like extractions. Okay, so position and function of interradicular fibers. This is, it's not on that picture either, but it's in between the roots, okay? I believe, in between the roots. The position is, the cementum to the furcation. So roots, cementum to the furcation. Okay, so they're right here in the furcation, and they're going to stabilize the tooth and socket. That's all they're going to do. So they really work with the apical fibers. Apical fibers don't want it to lift up out of the socket, but the function of those radicular is to stabilize that tooth. It's not going anywhere. It's going to be stabilized, okay? Almost done. 10 more. We're almost there. What happens with excessive removal of cementum? We know this. You take off too much cementum, there's going to be hypersensitivity. But this says produces exposure of dentinal tubules and loss of attachments of PDL fibers. We know that if there's hypersensitivity, it's because those dentinal tubules are exposed, and if it's exposed, it's because there's no attachment there, so there's loss of periodontal fibers. Here's a star. What is cementum formed by? Cementoblast of the PDL. We know this. So in the PDL, there's cementoblast and there's osteoblast, right? Because they help with the formative. They're going to build some bone. They're going to build some cementum. So what happens with excessive... Oh, that's the wrong one. Sorry. So what is cementum formed by? Star. Cementum is formed by the cementoblast builds cementum in the PDL. Awesome. Explain cementum. There is a star on here. Let's see what this is about. Okay, cementum we know is soft and permeable, okay? We think of Sharpie's fibers, Sharpie's fibers going into the cementum, so let's just think of that as semi-permeable, okay? So it's soft and permeable. We're not going to say semi-permeable, it's permeable. So it's soft and permeable because why? Because that periodontal ligament goes in there and it's got to put the nutrients in there anyway, so it's permeable. So bacteria and toxins can penetrate the cementum. So if your cementum is exposed, it is very susceptible to disease because that bacteria and toxins can penetrate the cementum because it's so soft and permeable, okay? Penetration is superficial, not deep. So it can penetrate into there, just not all the way through the dentinal tubules to the pulp. It can, but not right now, okay? Bacteria and toxins penetrate superficial, not deep. I don't know about that. But for this test, okay, bacteria and toxins can penetrate superficial, not deep. And okay, so cementum never regenerates after remove. Once it's gone, it's gone. We know that. It's avascular, okay? The top 2/3 are avascular. Bottom 1/3 is vascular. That bottom is where that little foramen is, that apical foramen that supplies the nerve. So just think the bottom of it is vascular, okay? That's where also the cells hang out at down there, because it's vascular down there. So the top 2/3, not vascular, no lymphatic vessels, no nerves, no blood vessels in the top 2/3, okay? It's at the bottom where that little nerve feeds the apical foramen into the pulp chamber, okay? So cementum, soft and permeable, okay? Bacteria and toxins can penetrate the cementum, but it's superficial, not deep, okay? Cementum and enamel relationships. There's a star here. We actually know these. So 60 to 65% of cementum overlaps enamel. Cementum overlaps enamel. Nope, that's not going to work. Cementum overlaps enamel 60 to 65% of the time. 30%, so let's think about half of that. The cementum and enamel just meet, okay? 5 to 10%, just a little bit. Cementum and enamel does not meet. Dentin is exposed, possible sensitivity, or caries. We want that cementum to overlap that enamels. That way there's no exposure to the dentinal tubules. So 60 to 65% enamel overlaps. Half of that, 30% where it just meets. 5 to 10% is where they don't meet at all. Almost there, a few more. What part of cementum is cellular? We know this. Apical 1/3. The bottom 1/3, because that apical foramen at the bottom that supplies that that pulp chamber, we know, boom, apical 1/3 is the vascular cellular part of cementum. There's a star here. Hypercementosis. Hypercementosis. Periapical cemental dysplasia. A lot of words, right? So it's just the thickening of cementum, usually at the apex, due to unknown causes. It could probably be super eruption, but we really don't know. If it's super erupted and there's not a tooth down here, you miss this tooth is going to grow down because it wants to touch something, right? And then you're producing more and more cementum here, so it grows down, super eruption. It's periapical cemental dysplasia, thickening of cementum, usually at the apex, due to unknown causes. We got that. 4 more. Alveolar bone morphology. Ew. Okay. Follows line from CEJ to one tooth to CEJ of adjacent tooth. Okay, so we know that. Alveolar bone, we know, is going to follow the contour of the CEJs. Okay, that's what we want. Because remember, in vertical bone loss and horizontal bone loss, you got to look at the CEJ to tell. From CEJ to CEJ, okay, is it horizontal? If the CEJ is down like this and you've got this, it's not vertical, it is horizontal, right? CEJ to CEJ is the alveolar bone morphology. What are the 2 defects of cortical bone? Okay, fenestration and dishiscence. I don't know how to remember this. Let's see. What is fenestration? Fenestration is the window, okay, of bone loss on the lingual or facial aspect of a tooth that takes place on exposed root surface directly in contact with gingiva or alveolar mucosa. Hold up. Okay, so what we're going to know here is the fenestration. So there's a fence right outside of my window. I don't know. That's all I could think of. It's the window of bone loss. Remember that little tiny window of bone loss? Fenestration. There's a fence outside my window. Okay? Dishiscence. And dishiscence. This is starred. And the last one. Whoop whoop. It's a dip or cleft, completely destroyed. Dishiscence, destroyed. Dishiscence, destroyed. Okay, whoa! That's chapter 2. I got to keep going with the other chapters because there's so much and we don't want to be here all night. But let's study together. Let's do it. Hope this is helping. That was chapter 2, Perio. Bye! Dishiscence, completely destroyed. And fistration, what was that one? Fenestration, there's a fence outside my window.